This is the notes for section 6.3 graph translation theorem, and what this is going to lead to is our second form for quadratic equations, and that is writing a quadratic in what we call vertex form. So in order to do that, we have to first understand what graph translation theorem says. And graph translation theorem just says in a relation described by a sentence in x and y, so a relationship between x and y, the following two processes yield the same graph. If I replace x by x minus h and y by y minus k, it has the exact same effect as taking a graph and translating it using the translation hk. Okay. Now thinking back to geometry when we did a translation of hk, this first number h told us how much we were going to change our x value. Or in other words, if it's positive, we're going to move it to the right. If it's negative, we're going to move it to the left. And the k value told us how much we were going to move our graph vertically, either up if it was positive or down if it was negative. Okay. So that's what the graph translation theorem does. So let's see if we can apply graph translation theorem to example number 1 here. It says find an equation for the image of the graph y equals the absolute value of x under a translation of 3, negative 5. Well, if I'm going to do a translation of 3, negative 5, really that means that we're going to take our x value out and put in its place x minus 3. And we're going to take our y value out and we're going to put in its place y minus a negative 5. So let's do that. So instead of y, I'm going to put y minus a negative 5. Now think about what that means. Y minus a negative 5 can be replaced with a plus. So I'm going to get rid of that and just put plus 5. And then that's going to be equal to the absolute value of x minus 3. So this equation would be the translation image of this. And let's take a look at the graph and see that that's the case. So here I have the graph of y equals the absolute value of x, and that's this red graph here. Now I'm going to graph y minus k equals x minus h. And right now you can see my h and k are 0, so it's the exact same value. But now I'm going to change it to what we had here. We had an h value of 3, so I'm going to move that over 1, 2, 3. And we have a k value of negative 5, so I'm going to go down 5 with that. And notice how it's the exact same graph, just been translated. Alright, the graph translation theorem applies to any relation between x and y. So if that's the case, we can apply it to quadratics. Well, our most basic quadratic is a quadratic of the form y equals ax squared. And let's just take a quick look at what that looks like graphically. So here's y equals ax squared. Right now I have a equals 1. Now I can move a around. You'll notice that it changes. As soon as it goes negative, it turns upside down. And when it's positive, it's right side up. So it opens up if it's positive, opens down if it's negative. Okay, so that's y equals ax squared. Notice how the vertex, the lowest point on the graph, or the highest point on the graph, in other words, where it changes direction, is at 0, 0. Okay, so y equals ax squared. So what we want to do is we want to take that graph and translate it to get other parabolas. Well, the graph translation theorem allows us to do that. It says under a translation of hk, the parabola with the equation y minus k equals a times x minus h squared. In other words, we've just taken out y and put in y minus k, and we've taken out x and we've put in x minus h. Now, we could also write it like this by adding k to both sides. You'll see it written both ways. Either way is fine. Okay? Most of the time I work with it in this way, but either one of these is fine. This is referred to as vertex form for a quadratic. It's a very important form. Now, the reason why it's called vertex form is because it will always give us the vertex. The vertex of our parabola will always be hk. That's the minimum value. In this case, if a is negative, it would be the maximum value. Now, it also tells us exactly what our axis of symmetry is for our parabola. A parabola is going to have an axis of symmetry, and that is the line that goes through that vertex point. So whatever our h value is, the axis of symmetry is going to be x equals that value. Okay, so it's a really important form for a parabola because it gives us both the axis of symmetry and the vertex right out of the form of the equation. All right, let's use the vertex form of a quadratic then to do example number 2 here. It says, what are the coordinates of the vertex of the parabola with an equation of y plus 4 equals 3 times x minus 2 quantity squared? So what we want to do is we want to think about the form for a quadratic when it's in vertex form. And we know that's y minus k equals a times x minus h quantity squared. Now what I would maybe do is I would think about what those different values are. We need to know what k is, we need to know what a is, we need to know what h is. So let's start with a. A is equal to 3. Now all that really tells me is that my parabola is going to open up. H, okay, so it's minus h, so it's always going to be the opposite of whatever this is right here. So in this case, h is going to be 2. And then k is always going to be the opposite of whatever we have here. So k is going to be equal to negative 4. Now, from that information, you'll notice as I'm thinking about graphing this parabola by hand, the first thing that I want to do is I want to get that vertex. And to get that vertex, once I know what h and k is, that represents the vertex of my parabola. Okay? Now, the other thing, let's go back to a here, and it says, write an equation for the axis of symmetry of that parabola. Well, the axis of symmetry we found out was always x equals h. Well, since h is equal to 2, in this case it's x equals 2. That would be our axis of symmetry for a parabola. Now let's continue to see if we can graph this by hand. To do that, I'm going to start with the vertex, and then I'm going to pick points on either side of that for x, and then find the y value. So let's pick points. So let's pick 1 and 3, and maybe 0 and 4. And let's plug those values in for x and find the y values that go along with it, just so we can get a decent idea what that graph's going to look like. Why don't you do that right now and then restart the video. So here's the values that you should have gotten when you plugged those values in for x. Those are the y values that you should have had. Now let's take those ordered pairs and graph them on our graph over here to get our graph of this equation. It always helps to start with a vertex and then pick values that are like 1 unit away on either side of that vertex, because we know that they're always going to be the same y value. So here's what that graph should look like, and then we can go ahead and just draw that curve in. Doesn't have to be perfect at that point, but you should be able to get some basic values like that. Okay? Alright, we can also use the graph translation theorem to come up with an equation for a new graph. So we have an equation y equals 1/3 x squared, and then we've taken that equation and we've translated it to get this graph right here. So that means that they're the same graph, just translated. So what we want to do is we want to come up with the equation for this new graph over here. Well, I know that a translation image graph will always be y minus k equals a times x minus h quantity squared. So there's really 3 numbers I need to know. What is a? I'm going to put that over here. Well, what is h and what is k? Well, we know that a is always that number that comes in front of x squared. So my a value is 1/3. We know there's 2 ways we can find h. We can find it in the equation here, but we can also find it from the vertex. It's always going to be the x value of the vertex. Therefore, h is going to be -3. And we know that k can be found from the equation here. It also can be found from the vertex. Therefore, the k value is 1. So now all I have to do is substitute those three values into my equation. So we have y minus k, or y minus 1, equals a, which is 1/3, times x minus h, which is a negative 3. Therefore, I'm going to write that as plus 3 squared. And we have the equation that we're looking for.